welcome to another episode of Pokémath. My name is Stefan Eriksson, and today here in episode number 57, we're going to be taking a look at To ID or Not to ID, the Worlds Edition. And more specifically, the question goes on day 1 at Worlds. So hold on before you start complaining. Let's hear first the whole setup before we get to it, shall we? So, a little background first. What is an ID at all? Because some people may think, yeah, that's my ID card, my wallet or so, but no, in terms of Pokémon TCG, it stands for intentional draw. That is, the two players agree to draw a given day a game, or to simply just tie a given game, right? And that was something that was reintroduced as a byproduct of ties. Yeah, that came again in the season of 2013 and 2014, so it's already quite some years ago, and we actually had this for quite a number of years. And in fact, what actually happens in a regular event is that if players decide to ID or intentionally draw in the last round or rounds in order to go into a certain top cut, you will increase the average number of points required to reach it. It has given quite some controversy over the last couple of years, whether it is the right thing to do or the spirit of the game. That's not exactly what we're looking at here today. That's a completely other discussion that I would like to stay out of. But in order to see what I mean by the average number of points required, I quickly simulated an event that I also used for an article I wrote back on 60 cards quite some years ago, in fact. So in this particular example, as you see here, we first see that everybody just decides to play out the last round, such that there's no ties. And in this particular case, we look at my brother, which is Simon Slaughter Eriksson. In this example, he ends up at 8th place, where you need 9 points, or at least you see here, 4 players with 9 points move on to top cut. If now, on the other hand, people would have ID'd, as you see in this particular case, only 1 person with 9 points have moved into top 8, which then also means that the average number of points required to make top cut is higher given the IDs. That's just how it works in a normal event. However, we have a little different type of question here today because we're looking at day 1 Worlds in very specific scenarios. Because we can quickly agree, knowing the Worlds format, or the Worlds tournament structure to be precise, that ties are pretty bad. So it's not to say ties are good at all, but there are maybe certain scenarios where you actually wish to make an ID. At least when we look at it from a pure statistical, mathematical perspective. Whether you feel it's the right thing to do for yourself or not, I leave that to you. Today we're only looking at it from a pure numbers point of view, right? Math, statistic, whatnot, we're just looking at the numbers. And we also, I would like to put out a disclaimer here, this quite say simplistic view. We could improve this a lot, but this should indeed give the gist of what I am trying to put forth. So in this particular case, first, what makes Worlds a little different than other events? At day 1, it's a certain event, it's a separate event from the day 2 Worlds. So any points you gain on day 1 will not carry over to day 2, unlike a regular regionals or internationals. Which also means that when you reach the number of points that you have required, or you require in order to move on to day 2, you will no longer play an event, you will simply be dropped from the event. So if we are to play 9 rounds on day 1, which is the example here today, but it perfectly works also if you only have to play 7 or 8 rounds, say, then you'll be dropped from the event the moment you reach the required number of points, which for 9 rounds will be 21 points. That is, you need either 7 victories or 6 victories and 3 ties would also do. You cannot go up and do 8 victories because you already dropped from the event before you even reach your 8th victory. In any case, if you reach that far, well done and congratulations, and well, get ready for the next day because you got another day coming in with day 2 right after. So as I say here, the number of points required depends on the number of players because that depends on how many rounds we have. I actually think that the current schedule says we should have 8 rounds, so that's what they're scheduling for, but nobody really knows before we're getting there. And as they also say, event structure is subject to change. So all this here is based on what we've seen so far, and they could just change it. But still, you still have to see whether you would have to ID or not in certain scenarios. So I'm going to present to you 3 scenarios here today. First, we start with what I would like to call the trivial case. What do I mean by the trivial case, or the trivial solution in this case? Suppose now, with 9 rounds, you're currently 6-0-2. That means that in this particular case, you sit down with your opponent, and given that you're not been paired down, that is, your opponent has the same score as you or not a lower score, you would choose the ID. There's absolutely no point to not ID in this case. It's a complete win-win. Both of you move on to day 2. You're not harming anyone. You're not increasing the average number of points required or anything, because everybody reaching that certain number of points will qualify for day 2. So if you find yourself being 6-0-2 and paired against another 6-0-2, ID. There's simply just no other way. You really have to have, say it could be a thing you just have against it, plain, fair, or you really have to dislike the other person sitting in front of you. In any case, I would recommend you to ID in this case. That should be pretty straightforward. That ends scenario 1. Now let's go to scenario number 2, and this is where it already starts becoming a little more interesting. Because suppose with 9 rounds day 1, your current score is now 6-0-1. That means there's 2 rounds remaining. And then your choice is, should you actually try and play for 1 win, or should you just try and ID twice? If you ID twice, you move on to the next day. And if you win any of your remaining 2 games, you will also move on to the next game. The quick viewer may already notice a simplification I'm making here. We're going to get back to that in just a moment. Before I made all this here, a week or 2 ago, can't even remember when, I posted this poll here on Twitter because I thought it was funny to just ask. And so I considered this hypothetical scenario where I basically asked, would you ID or play? And as I would expect, most people actually try to ID twice. Although this is very noisy data, I do admit asking open polls on Twitter and these kind of things are certainly biased, but in any case they give an indication of what people believe. I don't know whether people answer this for fun or not, or just try to troll. I would never know, but at least the indication here is that they would try an ID twice, at least the majority, which I also would agree with in this case, personally speaking. But let's see whether from a statistical point of view this is actually a better idea or not, because there's a few things that this depends on. First of all, this will depend on whether the risk of being paired down is big enough, how you would consider that, and what is your perceived chance of winning a game if you are playing. Those would be the 2 ingredients we're going to use, and that's what we're going to use to make decision trees. So in a very simplistic approach, I'm just going to make 2 types of decision trees here. One if you're playing, if you wish to actually play, and one if you wish to go for the ID. Then we're going to compare the outcomes here and see which one provides the higher probability of moving on to day 2. So basically I take one, subtract the other, and then we see whether that's a plus or a minus. If it's a plus in this case, I actually think it would be preferred to ID, but we're going to get to the table in a moment. And if it's a negative number that's going to show up, you would prefer to play. That's the way I have postulated in this case here, or put it up, so to speak. So we're going to compare the 2 outcomes and simply, get to it. And I think there's no further thing in the way further than drawing it, but you may also want to notice here, indeed, 2 ingredients needed. Just to recap that quite a bit. You need your perceived chance of winning a game if you decide to play, and you need the chance of not being paired down. You could also just say the chance of being paired down, but I found it easier to flip it around and say the chance of not being paired down. That is, again, for paired down, for those who are not sure what it is, it means you're meeting one with if you're paired down, you meet one who has a lower score than yourself. You could be sitting at, say, 6-0-1, and then you meet one with a lower score. That could be, for instance, a 5-1 score. Just an example. And that person will definitely not be interested in IDing, and therefore you would have to play. Now, let's try and draw the trees. So the first tree we're going to look at is suppose you want to play. And then here comes the first simplification. That is, in this particular case, I actually do not take in ties to account. And this is one of the biggest things you could talk about here. But what I would like to believe it does is that any estimate I get out of this here is a conservative estimate. There is, of course, a push and a pull here. one hand, if I include ties in this case here, you could also say, yeah, I rather want to play because I could always tie and then I'm back in the ID scenario. But I could also turn around and say, by including IDs here, you would actually increase the likelihood or the percentage possibility that you actually wish to just ID in the first place, right? Because why we didn't take the risk. So there's a completely different discussion here, but in this simplified scenario here, you can either win or lose if you decide to play. And then we have this nice little tree here. And what you see over here is that in the first knot here, so in the beginning of the tree all the way to the left, you can either win the game or lose the first game. If you win the game, you're done. That's it, you're dropped from the event in a good way this time, you're moving on to day 2. If you lose the round, you still have one more chance in the 9th and final round in this case. And then if you win, you move on. If you didn't lose, you're out. So you have to lose twice or just win 1 out of 2. And in this particular case, well, let's see what the probabilities are. And with the example values I'll be using here, as you can see above here, the perceived chance of winning will be a 50-50 coin flip, and the chance of not being paired down will be 80%. I will show for other numbers here once I've shown this example here, so take it easy. But in this particular case, it's easy to use those numbers. So if you decide to play, it's a coin flip. I will argue we should never go lower than that, because if your perceived chance of winning is lower than 50%, why are you even playing? Why don't you just try the ID? That's at least my opinion. I also think that's correct, but please, that's what we have a comment section for. And also the chance of not being paired down 80%, I actually would like to believe is rather low in this case. I think the chance of not being paired down is actually higher based on empirical evidence we've seen in different events, although we only have a very small sample size when it comes to worlds, and it's actually really hard to dig up. So the sample I'm basing this on is on regular regionals and internationals. So regular 2-day events. You can also just talk about any kind of event actually now when I come to think about it. So wouldn't worry about that too much. So carrying on with the example, what we then do, we will sum out the good outcomes. That is the outcomes where you will move on to day 2. So we got 50% plus 25%, making now in this case here for 75% total. So you see here 50% and the 25%. We add those up. That means if you decide to play, you got 75% chance of moving on to day 2. It doesn't sound too bad. Now, let's move on to the other tree, shall we? Because now, suppose you wish to try an ID. This tree here will move with the same example values as before, otherwise we're comparing apples and oranges and we don't want to do that. In this particular case, each of the knots that you have here have 3 outcomes. So in the first game here, you can either decide to ID if possible, because of course here comes another assumption. I love assumptions, I guess. That is that if you wish to ID, your opponent also wishes to ID, if in the same scenario as you. So of course, there may be a chance here that the opponent for whatever reason don't want to, and that's fair. We cannot force anyone to do it, and nor should you. But that also means there's 3 outcomes here. It means you either ID, or you play and win, or you play and lose. So in this particular case, we get this kind of tree. So if you ID the first time, you move up to the next round here. Here you can ID again and move on to day 2 because you ID'd twice. And now you could also ID the first one, then you could be paired down and you have to play. And if you lose, you're out. And if you win, you are in. And likewise, if you then don't ID the first round but then play and win, you're also on to day 2. But if you then play and lose, you still have one more shot in the 9th and final round. If we attach the numbers here, then we get the following outcomes here. You can always double check if my math is correct, but just to give you an idea of it, you take 80% to the power 2, so 0.80 squared, and you get 64%. And then you can also say, okay, we then have 80% of moving up here, that means there's remaining 20% here. With a coin flip, that means 10% here, and the remaining mass goes down here and split into 2, 5, 5. Just to give you an example how to quickly calculate that, but please double check my math because I just did this because, well, I think it's fun anyway. So then what we can do here, we can simply sum up all the good outcomes once again. That is 64 in this case. We have one with 8 here, we got one with 10 and one with 5. Those are all the knots or the outcomes here, which is positive for you. That is that you move on to day 2. In this particular case, of course, there's the simplification alert that yes, we could actually just have simulated the actual not paired down chance. It relates to a bit what was done in the previous app, the Swiss standing calculator. However, that has not been updated in way too long. So in this case here, we just go with this here. But we could actually simulate it. Maybe we should look into that in a future episode perhaps. So in this particular simplified outcome, we'll have to go what we have, right? So we are not simulating the actual not paired down probability. So now we have 87% here, and if I remember correct, we had 75%. We can now put this all together in a table with different numbers. So here you got a nice big scary table, favorite thing to do. So let's first figure out where were we before with our example. We were at this spot. And here, don't be alarmed. This is just me writing up all the probabilities from one tree. So the tree of playing, or the tree of IDing, minus the tree of playing. So those are the two decision trees. I summed up the good outcomes of each and subtracted both of them, landing here at 12%. I have, for simplification, just put 4 decimals here, and they're all in decimal numbers. And then I also shaded here further green, the higher the positive probability is, or say the higher the value is. So it also means that up here in the most upper right corner, you say you have a coin flip chance of playing or winning if you play, and the chance of not being paired down is 97.5. So that gives you more than 23% chance more chance of going on to day 2 if you decide to ID compared to if you play. You can figure out what do you feel is the correct for you and what you think is the most realistic, and simply figure out what is the number here that corresponds to that scenario. So again, if the number is positive, that means that the ID scenario is preferred. Mathematically speaking, statistically speaking, there's many other things here. And if it's red, it is preferred to play in this case. Again, I decided to go on the value starting from 50% in playing up to 95. And over here, I did different increments of 2.5%. So 5% increments here on each of the rows, and each of the columns have increments of 2.5%. You can of course just expand this a bit, but then the table of course will become a lot larger. So I decided to keep it here at a nice little 10 by 10. And down here in the lower left corner, we see the same question I posed in the beginning. So in this particular example, with these example values, you have a 12% chance more of moving on to day 2 if you decide to ID. That's only in this particular case, but that still leaves us the third scenario. And indeed, Slowpoke, we're going to use the same application as before. We're going to draw some trees. But this one is way more interesting in my opinion, because now suppose you're 6-0, which if you made it that far, well done. You're damn good. That's really good. I wish I could do 6-0 at day 1 Worlds. Guess there's only one way to figure it out. Now, if you're 6-0, you got a couple of choices. You can try to ID 3 times. Already sounds a little more risky, doesn't it? Or you can simply try to play, and then you just have to win one of them. And of course, given the simplifications here, you could also just play and tie, and then you naturally tie, and then you'll be back in the scenario from before. But we don't take that into account here. So the numbers I get out here, I would like to say, is a conservative estimate. That is actually a lower estimate for IDing than maybe the real number would be. Here's the question I posted on Twitter. This was actually the first one I posted because this is by far the most interesting scenario. So in this particular case, the majority prefer to actually play. And I kind of get that, to be honest. And I also, before I start calculating all these numbers, I was dead set on IDing being the better choice, I admit. But as you're going to see in the numbers here, I may be wrong. So that's why I start to crunch the numbers, and I'm showing you the results here today. But Twitter, or the public in this case, I even think there was almost 1,000 votes on this, which is pretty good. The other one had a little more than 400, I believe, or almost 500. So good sample size in any case. But in this case here, almost 3/4, roughly 3/4, prefer to play. And I get that, because then you take matters into your own hand. In hands. English is very good today. Now let's move on to the first tree. You decide to play. We're going to use the same example values as before, just to keep it comparable and rather simple, because these values are easy to calculate with. And then we're going to make the table afterwards. So first tree. Wait a minute. That's the tree from 4. Let's expand on that a little bit. There. We need a third round here, because we have the same scenario as before otherwise. So you either win the first one and you're good, you lose one, win one, you're also good, you lose twice and win one, you're also good. So those are the 3 outcomes that you want. We sum them all up, just like before, with the same simplification alert as before, with that we're not considering ties. So you sum them all up and now you get 87.5. That sounds pretty good chance. Pretty high, with a perceived chance of winning of 50%, of course, which is a coin flip. And I assume also you believe in your own abilities and probably actually would put your own value slightly higher than 50%. But still pretty good. Let's look at the other tree. That's also where it becomes a little more tricky to calculate. So same example values as before. This is the tree from previously. We now expand on it with another round. Same simplification alert as before, of course, with that we don't simulate the number of paired down that you would have to look at your own empirical evidence for. But I would like to say that the not paired down of 80% is actually rather low, I believe. So, okay. Now, in this particular case, you have the same here in the first 2 knots here. We just add a 3rd round. You need to ID 3 times to move on to day 2, or ID once, be forced to play and win, or ID twice to be forced to play and win. And that could be because paired down or your opponent doesn't want to ID. But we're assuming here if you can ID, you decide to ID. That's a simplification again. Or you could also, in the very first round here, so there'll be round 7 out of 9, be forced to play, win, and you're good. You could lose, and then you still have 2 more shots of winning. We sum up, or we calculate all the probabilities, and we sum up the good outcomes, and we actually end here at 87.1%. And now you can be quick to think, wait, that's lower than playing. And indeed it is. So in this particular example case here, there's a slight better chance of moving on to day 1 if you decide to actually play. So that's interesting, isn't it? And of course, putting up the matrix here as before, boom, it's a lot more red this time. And not that red is bad, it's just nice contrast to green in this case. Or, I hope nobody's colorblind out there, otherwise let me know, otherwise you just have to look at the numbers. But what you do see here indeed, it's in many instances preferred to play here actually, over IDing. But that depends on the numbers you attach to it, of course. If you believe, for instance, that the chance of being paired down, or not being paired down, is say around 95% all the way up here, then of course in most cases you would actually prefer to, well, ID over playing. A lot vice versa, if you have it differently, you can also get here. But you also see here that in any case, the numbers here, they may seem very red, but they're actually not that many percentages lower. So the upside is still higher for IDing, but then again, this is a very simplified scenario, so I could perfectly understand why a lot of people would strongly prefer, or just prefer, to play rather than IDing in this case here. This is how you will calculate this spot here, and don't be alarmed, don't be confused. This is just, I just dunked it into Excel and got it from there. And I could probably done this a lot smarter, but that was what I had in mind at the time. So, and here again is the question for before, same thing where you can see the majority actually wish to play. But I hope this will give some clarity, or at least an idea about what is actually the preferred choice, to ID or to play. In any case, with the 6-hole one, I can comfortably say I believe it's better to ID. But in this 6-0 scenario, it may be a little different. There's also another argument that we should actually not forget about. And of course, that is the fact that if you sit there at the tables, at the top tables, and you're all 6-0 with 9 rounds, then it's sort of a prisoner's dilemma in the sense that if somebody decides to play and the rest to ID, all the people who ID are technically worse off because there's going to be less players to ID with in the rounds to come. That's so you sit there and actually your choice depends very much on are other people's playing or not, and you know that's kind of a prisoner's dilemma. Not a clear one, but it's sort of there, right? So there's also this argument to be made. That's a completely other, more psychological video that could be made at that point. But what did we look at today? We looked at whether you should play ID in certain scenarios, right? And of course, there were the limitations we discussed, the simplifications, and also a few other things here. So to list some of the limitations again, we could include ties when you decide to play, or I could also simulate the risk of down pair. But honestly, I didn't have that much time, so this was just a nice little quick version of doing it. So I hope you enjoyed this video here today, because I think that was all I had to say about it. And feel free to leave a comment below. Maybe I missed something. This was just something I just scratched down on a piece of paper and then put into Excel and see what I got out of it. And I thought it was really interesting, so I want to share it with all you guys. So I hope you enjoyed it, and yeah, I hope you enjoyed this class in Stefan's Classroom, and well, I hope to see you back for another class in Stefan's Classroom. Bye bye, guys!